Okay, isoelectric focusing. Let's discuss about isoelectric focusing. Actually, isoelectric focusing is an electrophoresis technique that separates proteins based on their isoelectric point. So, isoelectric focusing is a technique that separates protein based on their isoelectric point. So, first let us know what is isoelectric point. Isoelectric point means particular pH of a protein where its net charge is zero. Means like in this isoelectric point. So what is isoelectric point? For example, the, there is a particular pH. Okay, and in that particular pH, if the protein's net charge is zero, then we call that particular pH an isoelectric point. So in this isoelectric focusing, the separation is achieved. That we can achieve this separation by applying a potential difference across the gel that contains a pH gradient. And this pH gradient, first we have to add ampholytes. That these ampholytes are mixtures of synthetic polyamino and polycarboxylic acids, commercially known as biolite or parmalite. That in the gel we have to add that biolite or parmalite, and after that pH gradient will be maintained by applying the potential difference. So what is procedure? First, we have to make a 4% polyacrylamide gel of 0.15 millimeter thick. So for making that 4% means like we make 4% means very less percentage of polyacrylamide gel. This is to ensure that there is large pores between the gels to avoid sieving effects of the proteins. Like for example, we want to separate the proteins according to the isoelectric points, and if the large molecular size proteins get stuck, then we won't be able to separate the proteins based on the isoelectric points. So we need to make sure that all the proteins pass through the gel. So we make 4% polyacrylamide gel. Then this polymerization of the polyacrylamide gel is done by light. Then how it is done by light? First we have to put riboflavin. Along with the acrylamide. Then after that we have to put these ampholytes, and after that this mixture will be will this mixture will be polymerized by light. Means that we have to do photo decomposition. Then while doing photo decomposition, this riboflavin will be converted into free radical, and this free radical will take up another monomer acrylamide. Then after that it will take another monomer acrylamide. Like this polymerization will be done. Then we add cathode and anode. Then after adding cathode and anode, under the effect of the potential difference, the pH gradient will be formed. Then after adding the protein sample in the middle, we have to add protein sample in the middle, and after that the separation will start. Then how this separation will be done? For example, a protein that contains more negative charge will move towards the anode, and while moving towards the anode, according to the pH gradient, it will obtain more and more positive charge, because this anode contains low pH. Like it contains more acidic medium. So means like it contains more hydrogen ion. So while moving along this way to the anode, these proteins will become more and more positive, and there will be a time when all the positive and negative neutralize each other, and the protein carries zero charge. Means like if it carries zero charge, then it won't move further, because the anode cannot attract the zero charge protein, and in this way the proteins will stop moving, and by this the proteins will get separated. And if the proteins contains more and if the proteins contains more positive charge, then it will move towards the cathode, and while moving towards the cathode it will acquire more and more negative, and finally a stage will reach where the net charge on the protein is zero. Means like positive becoming more and more negative, means like there will be a point when all the positive and negative neutralize each other, and in that point the protein will stop moving. So like this, like this the proteins will get separated. And after this separation we will do staining. Why staining is done? Means like staining is done to find out where the protein is. So but uh, this staining cannot be done directly because the ampholytes will get stained too. So in order to do that we have to first wash the gel with a fixing solution which is trichloroacetic acid. Then after washing the proteins with trichloroacetic acid, the proteins along with the gel will get precipitated and the smaller ampholytes will get washed. Then the gel is stained with Kumasi brilliant blue. And uh, and uh, and first and before all these procedures, before adding the protein samples, no, when adding the protein samples, then in another column of the gel we have to add those protein mixtures of non-isoelectric point. So like we know the isoelectric points of some proteins, and we will make them run through another column. This will act as markers to identify which proteins is getting separated. Okay, this will run on another column. And advantages, like it will be used for micro heterogeneity in a protein, like a small difference in the charge will form different bands in IF gel, while it won't be in SDS gel. In SDS gel the proteins will get separated. Will get separated according to their molecular weight. So in IF gel, a small difference in charge means like a small difference in charge means there will be a difference in molecular weight also, but in SDS space it will be able to separate it, but in this process it won't be able to separate. And it is also used in separating isoenzymes which differ only in one or two amino acids. Thank you.